Now let's find out the minimum speed for starting a centrifugal pump. Now the centrifugal pump will only be able to deliver water if the pressure head rise in the impeller, I would denote that as HP, is more than or equal to the manometric head. Then only the water delivery from the centrifugal pump will start. Till the time it is less than this pressure head is less than the manometric head, the water will keep on rotating inside the impeller. Okay, and that kind of a motion is called a forced vortex. It is called a forced vortex. Okay, but the delivery will not be there from the centrifugal pump. Now let us say that the centrifugal head, this is equal to omega square R2 square by 2g minus omega square R1 square upon 2g. Now we know that the tangential velocity is omega r, so this becomes u2 square by 2g and this becomes u1 square by 2g. So this centrifugal head is the pressure head rise in the impeller. So this can be denoted as HP. Alright, and this HP, that is the pressure rise in the impeller, this should be greater than or equal to the manometric head to ensure delivery of water. Okay. Now our focus is to find the minimum speed. For minimum speed, we have to put the minimum condition. So the minimum limiting condition is equality. So you will have u2 square minus u1 square upon 2g. This is equal to hm. So this is the minimum or you can say the condition to find out the minimum speed. Okay, now if you write down the value of the overall, the manometric efficiency, this is equal to G into HM by VW2 into U2. So from here I can say that the value of HM can be found out as VW2 U2 by G into eta m. This is the value for the manometric head. Now this value of manometric head can be put here. Also we can put the value for U1 and U2. So U1 is pi into D1 n by 60 and U2 is pi into D2 n by 60. Okay, so we can put it over here. So you will get 1 by 2g into pi into D2 n by 60 square minus 1 by 2g into pi d1 n by 60 square is equal to eta manometric VW2 U2 upon G. That is the value of your manometric head. Okay, now we will divide the entire equation. Before I do that, let's put the value of U2 over here as well. So you will get pi into D2 n by 60. So what we will do now, we will divide the entire equation by pi n by 60g. That is pi n by 60 into g. So this is the term with which I will divide this entire equation. So when I do that, I get rid of the pi from the square and the n from the square. Okay, so you will have 160 is also gone, g is also gone. So you will be left with pi n upon 120 and this d2 square would be in the bracket. Similarly, you will have d1 square. Okay, so this is the value that you will get equal to eta m VW2. Okay, so you will divide that, so you will get rid of pi n 60 and g will be gone. So you will only have d2 over here. So from this equation, I can very well find out this minimum RPM, capital N. So capital N, this is equal to 120 times the manometric efficiency into VW2 into D2 divided by pi into D2 square minus D1 square. So this is the mathematical relation to calculate the minimum speed for starting a centrifugal pump. Okay, so I hope you understood this. Now let's look at some questions on this topic.